Alright, so I think this is recording. 26, we are doing problems from our review packet for Skill 3, Relations and Functions, and problem number 26 has three parts to it. In part A, they want me to find the domain of this new function, f plus g. Now, I don't actually have to find the expression itself to find the domain. It's not asking for the equation. It'd be easy to do. We would just add these together. But what I need to do here is find the domain of f and find the domain of g and intersect those two domains together. So when I look to find the domain of f, remember that the domain is the set of all real numbers, excluding any values of x that cause division by 0, and also excluding any values of x that would cause us to take the square root or even root of a negative number. So I have that on a previous video, or typed out. Let me go get that from that slide. I'm going to pause it and I'll be right back. Alright, so I'm back. So I hope, yeah, this looks to be recording. I think when that's blinking, it's recording. Alright, let's paste. I had used this on an earlier slide, so I ran and got it, went and copied it and pasted it for here. So when we look for the domain of f, we do not have any radicals, so I don't have to worry about taking the square root of a negative number. I do have to worry about that denominator equaling 0, so I have to avoid x equals 8. So in my domain for f, I want all real numbers excluding the number 8. So everything else is fine. So there's a picture for my domain of f. And if I were writing that in interval notation, I just use a little subscript to help remind me that this is the domain for f. And it would be from negative infinity to 8. I have a break in the graph, so I need a union, and then 8 to infinity. But that's not what they're asking. That's just the domain of f. They want the domain of f plus g. So let's shrink this up and keep this over here. Alright. So now I want to focus my attention on g and find the domain of g. So in the domain of g, I don't have to worry about division by 0 because I don't have any variables in a denominator. But I do have a variable that's underneath a radical. So this expression 2x plus 8, it has to be 0 or positive. It cannot be negative. So I solve this inequality. And I have that x is greater than or equal to, oops, I almost lost my negative sign, negative 4. Okay, so on a number line, I include negative 4, and since it's greater than, I shade to the right. So now I can use these two pictures to find my final answer for the domain of f plus g. So you might want to do this idea in the form of a picture with just 3 number lines. On our first number line, we want to include negative 4 and positive 8 on all 3 number lines. So if negative 4 is somewhere to the left of positive 8, and then this one is going to be my final answer. The idea of an intersection is that the x has to be in both sets to be in the intersection. So if I on the in the first one, on the top one, all real numbers except 8. So let's come in and shade in all real numbers except 8. And on the second one, we include -4 and shade to the right of -4. So let's start with these specific boundary points of interest, the -4 and +8. -4 is in both of these sets, so at -4 is going to be in my final answer the domain of f plus g. Now 8 is not in both, so 8 cannot be in the intersection. If I look to the left of -4, all of these values are in this set, but they're not in here, so they'd have to be in both to be in the intersection. If I look at the numbers that are between -4 and +8, they're in this set and they're also in this set, so they're going to be in my intersection. If I look at numbers to the larger than 8, all these values are in this set. Numbers greater than 8 are in this set. Since they're in both, they're in my intersection. So there's a picture of what my final answer is going to be. So let's shrink this up and give myself a little bit of room. So I claim that the domain of this new function that you get by adding f and g together will be from -4 to 8, excluding 8, and from 8 to infinity. Alright, now let's make a comment that if they had asked me to find the domain of f of x minus g of x, it'd be the same answer. If they would have asked me to find the product f times g, it would be the same answer. And even if they changed the order of addition or order of subtraction, it would be the same answer. Alright, so let's move on to part B. Let's take this with us. Although, let's take all of it with us. Let's take our and that we've already done that work. We've already found the domain of f and the domain of g. Alright. Well, you can go back to refer to that. I need the room, so I'm going to delete that. So I made the comment that our previous answer would be the answer for if it was f minus g, f times g, or g minus f, or g, the order doesn't matter. But with division, it might be this answer, but we might have an additional restriction because now f is in the denominator and we can't allow f to be 0. So when I look at the expression, I don't have to necessarily find the final expression, but let's write it out. The g of x is 2x, the square root of 2x plus 8. That's not going to give me any added restriction. I've taken care of the 2x plus 8 over here. Now, in the denominator, I have this x minus 8 in this denominator, and I've taken care of that. But now this x plus 1 that's in the numerator of f is actually now in a denominator. So I have to have the added restriction that if x plus 1 were allowed to equal 0, then the numerator of this fraction would be 0, and that fraction would reduce to 0. And since that's in a denominator, we would have division by 0, and we can't allow that. So we have to throw out -1 from our answer here. So when we in a sense have another number line to add to our picture. So let's go back and let's get these three. What I'm trying to get you to buy into is that I have an additional number line now, and this additional restriction is that x can't be -1, because if we evaluate this at -1, what do we get? Well, 2 times the -1, that's fine because we're adding 8 to it. So that's the square root of 6. And over here, I have -1 plus 1, and here, -1 minus 8. So in the numerator, I have the square root of 6. In the denominator, I have 0 divided by a negative, not 7, -9. But it doesn't matter. If I have a fraction that has a numerator of 0, then that reduces to 0. So this is the square root of 6 divided by 0, and that's where the problem is because I can't go any further. This is undefined. So I can't, for when x is -1, I don't have a corresponding y value. So therefore -1 can't be in the domain because it's not related to any y value. So I need to include -1 in my thought process of my intersection. So I had the first number line represented the domain of f. This represented the domain of f. This represented the domain of g, and this represents not g. F. That I wanted to prevent f of x from ever equaling 0 because it's in a denominator. So all of these values will provide us a value that's not 0. So -1 can't be in my final answer because it's not in all three sets. I'm intersecting all three of these sets. So to be in my final answer, you have to be in every set. And when we look at -1, it's in the first two, but it's not in this one. So therefore it can't be in the intersection. So my domain for g over f is the set of real numbers from -4 to -1. Make sure I didn't make a sign error there. Yeah, -1 plus 1 is 0. Union -1 to 8. Union 8 to infinity. So there's my answer, my final answer for part B. For part C, they want me to find the domain of the function composition. So let's think about what this composition means. We start with the second function g, and we input values from the domain into g. So this x has to be in the domain of the second function, or otherwise will not have an output. This output now becomes the input into the next function f. So any input to f has to be in the domain of f. The input to F this time is the output of G. If that output of G is in the domain of F, then the result we will have a result. Alright, now we've already found the domain of F and G. Let's go back and see if we can bring that along. Just trying to move this around and get everything in here. Alright, so the domain of this composition definitely is going to be either this -4 to infinity or some modification of it. Well, we've got to think about what F, this domain of F is all real numbers except 8. So we cannot allow G of X to equal 8, because if you plug in 8 into F, it results in a division by 0. So what X causes the output to be 8 is what we have to prevent. So this G of X is the square root of 2x plus 8, and we need to temporarily set it equal to 8 and solve this equation. If we square both sides, and now step by step try to solve for X, if I subtract 8 from both sides, I think I get 56, and half of 56 is probably 28. 28 and 28, yeah. So we can't allow X to be 28. So let's come back to the domain of G, which we knew was all real numbers greater than -4. And 28 is greater than -4, and we have to exclude that. So this domain of G gets that added restriction in order to prevent F from ever seeing the number 8, because I know that G of 28 is equal to 8. Because that would be the square root of 2 times 28 is 56, or no, 56, and 56 plus 8 is 64, and the square root of 64 is 8, but F evaluated at 8 is undefined, and we can't have that. So the domain for this composition is from -4 to +28 union 28 to infinity. So there's my final answer for part C. So I hope this helps, and I'll continue these, and I'll talk to you later. Bye.